Warm greetings students. This is Dr. K. Muruganathan, Assistant Professor, Department of Mechanical Engineering, Kamaraj College of Engineering and Technology. Today we are going to discuss about sections of solids. Actually, there are two types of sections. The section plane perpendicular to VP and inclined to HP. And the second one is section plane perpendicular to the HP and inclined to VP. Okay, let us consider this is a cylinder. If you are cutting like this, which is called as section plane perpendicular to the VP. See the things. If you are cutting like this, which is called section plane perpendicular to the HP. The sample diagram of sectioned views are given here. Here you can see the in front view you can see the sectioned plane. Here in top view you can see the sectioned plane. Different types of sectioned view. If you cut the section plane through the apex, you will get the triangular shape. If you cut the section plane through the generators, you will get the ellipse shape. If you cut the section plane parallel to the generator, we know that this is the generator. So if you are cut like this, you will get the parabola. And if you cut the section plane parallel to the axis, if you are cutting the section, you will get the hyperbola. And if you cut the cylinder through the generators, if you cut the section plane, you will get the ellipse. If you cut the square pyramid, through the slant edges, these two lines are called as slant edges. If you cut like this, you will get the trapezium. Let's see a problem. A hexagonal prism of base side 30 mm and axis length 70 mm rest on one of its end on the HP with two base sides parallel to VP. It is cut by a plane perpendicular to the VP and inclined at 30 degree to the HP. The cutting plane meets the axis at 30 mm from the top. Draw the front view, sectional top view and true shape of the section. The cutting plane which is inclined at 30 degree to the HP. Before going to section plane, we have to draw the simple position. They have given the one of its end on the HP. So hence they have given the simple position, and one more thing, they have given two base sides are parallel to the VP. So for that purpose, we have to draw the hexagonal like this. So here you can see the two sides are parallel to the VP. So we have drawn the simple position. After drawing the hexagonal shape for the given dimension, we have to project the line up to reference line, and then you have to draw the axis line up to 70 mm. We know that the base sides are 30 mm. Okay, now we have drawn the simple positions of the for the given hexagonal prism. Now we are going to discuss about the sectional views. Now we are going to see the sectional view. For that purpose they have given the data. It is cut by a plane perpendicular to the VP. Earlier we have seen cut by a plane perpendicular to the VP. So for the purpose we are going to cut like this and inclined at 30 degree to the HP. The cutting plane meets the axis 30 mm from the top. So from the top you have to locate the 30 mm like this, and then they have given the 30 degree to the HP, and then we have to extend this line. So we have located the sectioned view. Now I have shown the sectioned view. Now I have drawn the reference line to show the true shape of the section, and then you have to draw the perpendicular line from here, and then from here, and then from here, and then from here. Now we have drawn the perpendicular lines. Both edges are cut from the top view. You can see that the whole portions are cut. Hence I have given the hatches for the whole hexagonal. And then you have to, now I am going to give the name. This is the top view. So same thing I am going to represent in the front view. So here 2 dash, and then here if you see from here, first of all you will see the 3 dash, and then 1 dash is invisible, and then from here 4 dash, and 6 is invisible, and then 5 dash. Now we have to measure the distance from reference line to here, and then reference line to here, reference line to here, reference line to here. So we have to measure the whole 6 dimensions from the reference line. Then join the lines like this using rule scale or mini drafter, and then finally you will see the sectional top view. Now I am going to give the hatches. And then finally this diagram is called as top view, and then this diagram is called as true shape of the section. This is also called as sectional top view. Thank you.